Salam, peace be upon you. My name is Mohammed Layiq Sediqi, the father of Holophase. Remember the language we are learning. There is one field, phi, the holophase, one continuous cyclic movement from which all of reality unfolds. When phi begins to change, its first derivatives appear, and with them, the three dimensions show themselves at once. Time as omega, space as k, and motion as v, built from both. Every higher derivative is a finer question about how phi changes, and each one casts three shadows together: a time shadow, a space shadow, and a motion shadow. These echoes mix and weave into one another, forming the patterns we call fields, particles, bodies, thoughts, and worlds. In this picture, everything that exists is a living tapestry of phi, endlessly echoing through its derivatives and their dimensional shadows. Today, we focus on one essential component of the epistemic firewall. In this part 35, we arm the firewall with its most powerful diagnostic tool against self-deception. We define negative controls and placebo laws. This is the firewall mechanism that deliberately breaks the world to see if a purported rule is a real constraint or just a figment of our pattern-hunting imagination. The core revelation is methodological and profound. A rule must be tested against null worlds, shuffled windows, synthetic no-structured data, and controls engineered to destroy the relevant structure. If the law appears there, it is a placebo. The skill you will gain is that of a placebo tester. You will learn to construct and apply null experiments, situations where a real effect should vanish, to prove that your discovered pattern is not an artifact of your method, your hopes, or random chance. Our core question is precise. How do we detect false laws produced by pattern hunting, bias, or overfitting? This question targets the most insidious source of error: the human tendency to see patterns where none exist, and the computational tendency of complex models to find spurious correlations in noise. We have a candidate rule G. It fits the data beautifully. It passes initial checks. But is it a discovery, or is it a placebo law? A rule that appears significant only because we didn't check if it would also appear in a world deliberately designed to have no such structure. The placebo test is the ultimate reality check. It asks, would this rule appear even if phi had no such constraint? If the answer is yes, the rule is a phantom. Why is this test necessary? The failure mode it prevents is the epidemic of false discoveries. In an age of big data and powerful fitting algorithms, we can mine vast datasets for any pattern. Without placebo tests, we will inevitably find countless laws that are mere statistical flukes or artifacts of data preprocessing. This pollutes the scientific registry with noise, wastes resources chasing phantoms, and erodes public trust. The negative control is the mandatory inoculation against this disease. In holophase terms, we have a pipeline from phi to rule. We observe phi through windows W, get phi sentences S, and infer G. The placebo test creates a null world or a null dataset. This is not real phi. It is a synthetic or manipulated version of the data where the specific omega power sec VD structure that G purports to describe has been intentionally destroyed, while all other aspects of the pipeline, noise characteristics, distributions, etc., are preserved. The triunity provides the precise recipe for constructing these negative controls. We must be able to separately and jointly disrupt the echoes. Omega control, temporal null. Scramble the temporal ordering, randomize the phase alignment, or destroy rhythmic coherence. For a time series, you randomly shuffle the time order of the data points. This destroys any causal or dynamical time structure while preserving the distribution of values. A rule that depends on temporal sequence should vanish. K-control, spatial null. Randomize the spatial arrangement, break continuity patterns, or permute labels. For an image or spatial map, you randomly shuffle the pixel locations or rotate reflect parts arbitrarily. This destroys geometric and topological relationships. A rule that depends on spatial structure should disappear. 3. V-control, dynamical null. Destroy propagation coupling or scramble flow relations. For data involving motion or interaction, you can randomly reassign which entity is influencing which, or add random rotations to velocity vectors. This destroys the true causal or correlational links in the dynamics. A real rule should disappear when its required omega k pound V structure is destroyed. If the rule G is a true constraint on phi, it is a constraint on how those specific omega, k, and V patterns relate. Break those patterns, and the constraint has nothing to latch onto. The inferred parameters should become consistent with zero, or the rule's fit should become terrible. The formal procedure is: generate independent null datasets, D null I, where I runs from 1 to n. On each null dataset, run the identical inference pipeline that was used to discover rule G on the real data. This yields a distribution of null rule parameters, or null fit statistics. You then compare the result from the real data to this null distribution. If the real result is a clear outlier, for example in the extreme tail of the null distribution, the rule likely reflects real structure. If the real result sits comfortably within the null distribution, the rule is likely a placebo. It appears just as strongly in randomized data. This connects decisively to energy as tally. Placebo laws are particularly dangerous here. A false rule can generate apparent energy structure or conservation, even when the underlying omega kV coherence has been intentionally scrambled. This is because the energy accounting is often a derived, high-level summary. A flawed inference pipeline can impose an energy-like balance on random data. If your pipeline discovers a beautiful energy balance rule in randomly shuffled data, that rule is reading the pipeline's own mathematical tendencies, not reality. The placebo test exposes this by showing the energy signature appears even in the null world. The operational interpretation is the widespread use of permutation tests and surrogate data tests in statistics, neuroscience, and cosmology. In functional MRI studies, to see if brain region A is truly connected to region B, researchers will randomly permute the time series of one region thousands of times and recalculate the connectivity. If the real connection is far stronger than all the permuted null connections, it's likely real. In particle physics, the background estimate for a potential new particle signal is often generated by randomizing events in control regions, a form of null test. The firewall role, therefore, is that of the null world architect. When a candidate rule G is presented, you demand the construction and application of triunity negative controls. You do not accept the rule until it is shown to fail these null tests. You insist on seeing the distribution of results from the scrambled worlds. Your trust is conditional on the rule's demise in nullity. Let us formalize the test. Let T be the test statistic that measures the strength of rule G. For example, its effect size, its goodness of fit R squared, its inferred coupling constant. Let T real be its value on the real data. Let T null be the distribution of this statistic computed over M null datasets generated by the appropriate omega, k, or v scrambling. Compute the p-value in a frequentist sense as p equals number of null datasets where Tn may open yt real divided by M. A small piece suggests T real is unlikely to arise by chance from a null world. A large P suggests T real is typical of null worlds and G is a placebo. The firewall's threshold is strict. The rule must not only be statistically significant, it must be robustly significant against the specific null that targets its claimed mechanism. Let us state with crystalline clarity what is allowed and what is forbidden at this gate. What is allowed? You are allowed to discover rules through exploratory analysis. However, before a rule can be licensed, you must perform and pass tri-unity negative control tests. You must generate null datasets that disrupt the omega, k, and v structure relevant to the rule. You must show that the rule's signal is substantially stronger in the real data than in this null ensemble. What is forbidden? You may not claim a discovery without performing appropriate negative controls. Use a null model that does not properly destroy the relevant structure. For example, using simple Gaussian noise when the real data has complex autocorrelation. Hide or fail to report the results of negative controls, especially if they are unfavorable. Argue that a rule is theoretically motivated as an excuse to skip placebo testing. Even theory must survive contact with null data. What happens when the check fails? The license consequence is immediate and severe. Fail, immediate downgrade to artifact, mandatory assumption audit, Part 21 logic, and registry flag, fails placebo test. The rule is not just rejected, it is branded as a likely product of methodological artifact. Its proponents must return and perform a deep audit of their pipeline, the tacit assumption extraction protocol, to find out why it generates false positives. The rule is barred from the license registry and serves as a warning to others. Now, we must state the explicit prediction and falsification for the negative controls principle. Prediction, if the candidate rule is physical. If the rule is a real constraint on phi, it will not survive null shuffled controls beyond the false positive rate implied by uncertainty. The rule signal will be a clear outlier in the null distribution. Its parameters will be inconsistent with the null. Falsification condition for the rule's reality. If the rule appears robustly in negative controls, it is a hallucinated constraint. If you scramble time, space, and dynamics, and the rule still pops out with significant strength, then the rule is not about phi structure. It is an inevitable output of your analytical machinery applied to any data of that general type. The rule is falsified as a discovery. A canonical example from social science is the power pose phenomenon. Initial studies claim that adopting expansive, powerful postures, a KV configuration, caused hormonal changes, testosterone increase, cortisol decrease, and increased risk-taking, behavioral omega effects. The rule G was specific body postures cause physiological and behavioral changes. Later, rigorous attempts at replication failed. Crucially, placebo-level scrutiny was applied. Were the original results just random fluctuations? When similar analysis pipelines were run on completely random or scrambled physiological data, could they produce significant effects? The field eventually concluded that the original findings were likely statistical false positives, exacerbated by publication bias and flexible analysis. The rule failed the negative control test of scientific replication itself, the ultimate null test where the hypothesized cause-effect link is absent. It was a placebo law. Let us explore an analogy from the high-stakes world of TSIM. Evaluating the effectiveness of traditional herbal remedies, like Plantago or Ziziphora, for common ailments in a village clinic in Nangarhar. A local healer, Hakim Sahib, observes that patients who take his special preparation of Ziziphora tea seem to recover from spring colds faster. He proposes a rule G. Ziziphora tea reduces the duration of spring cold symptoms. He has observational data. 20 patients took the tea, their average recovery time was 5 days. Historical average in the village is 7 days. The rule seems promising. A young doctor trained in modern methods arrives. She is skeptical. She recognizes the possibility of a placebo effect and other biases. Maybe patients who seek out the Hakim are more motivated to get better, or the act of caring attention itself speeds recovery. The rule might be a placebo law. She designs a negative control test, a randomized, double-blind, placebo-controlled trial. This is the ultimate triunity null test for a causal rule. Design. She recruits 100 patients with spring colds. She randomly assigns 50 to get the real Ziziphora T, group A. She assigns the other 50 to get a nearly identical tasting tea made from harmless, inert herbs, group B, the placebo. Neither the patients nor the nurses administering the tea know who gets which. This is blinding. Group B is the negative control. In this group, the specific bioactive structure of Ziziphora, its hypothesized KBV chemical structure, is absent. Everything else, the ritual of tea drinking, the attention from the clinic, the belief in treatment, the noise of natural recovery, is preserved. If the rule G is real, causally dependent on Ziziphora's chemistry, it should fail in Group B. Recovery in Group B should be around the historical 7-day average. Omega control. She carefully tracks recovery time, omega, for all patients. KBV control. The randomization itself is a control over hidden spatial motional confounders like socioeconomic status, severity at onset, that could bias the groups. Results. After the trial, she finds Group A, real T. Average recovery equals 5.2 days. Group B, placebo T. Average recovery equals 5.1 days. The difference is negligible. The rule G appeared just as strongly in the null world, the placebo group. The effect was not due to Ziziphora. It was due to the context of treatment, the placebo effect, regression to the mean, or natural history. Prediction of a physical rule failed. The rule did not disappear when the specific bioactive structure was removed. Falsification condition met. The rule appears robustly in the negative control. It is a placebo law. License consequence. The rule Ziziphora T reduces cold duration is downgraded to an artifact. It is flagged, effect not distinguishable from placebo. The Hakim's observation was real. People got better with his care, but his inferred causal agent was wrong. The licensed finding becomes the context of receiving care in this clinic reduces perceived cold duration, which is a different psychological social rule. The firewall prevented the village from investing scarce resources in mass cultivation of Ziziphora for a non-existent specific effect, while honoring the real and important holistic effect of care. In Holophase science, the patient's body is a phi pattern. The T is an intervention. The Hakim's observation was a correlation in a noisy, confounded window. The randomized trial constructed a precise null world, the placebo group, where the hypothesized phi-active principle was absent. The rule's failure in that null world exposed it as a placebo law. This exact logic exposes false laws in physics. For example, signals that appear in one detector's noise. Economics, trading strategies that work on historical data but fail on randomized time series. And machine learning, models that perform well on training data but fail on shuffled labels. This discipline is the ultimate embodiment of the episode 11 axioms. Rules do not become real by elegance, consensus, or tradition. They earn a license only by surviving falsification, variation, independence, and scope discipline. The negative control test is a brutal form of falsification, testing the rule in a world where it must fail if it's real. It is also a test of independence. The rule must depend on the specific structure of phi, not on general properties of the data class. And the cardinal rule? When a rule fails, we do not believe harder. We tighten, downgrade, or retire its license. When a rule fails the placebo test, we do not believe in the herb harder. We downgrade the claim to an artifact. We retire the causal hypothesis. We may tighten the scope to works only in unblinded observational settings, which is essentially admitting it's not a robust causal law. The skill you gain from this part is skeptical engineering. You learn to build the counterfactual world that kills your favorite hypothesis. You develop the habit of asking, what would this analysis find if the truth were null? This skill is the bedrock of rigorous experimentation. It replaces hope with proof and pattern seeking with truth seeking. This skill has immediate, vital application. In machine learning, before declaring a neural network has learned the concept, you perform a randomization test. Shuffle the labels in your training data. If the network can still achieve high accuracy by memorizing noise, your original result is a placebo. The network's architecture is just a powerful pattern fitter, not a concept learner. In genetics, when you find a gene association with a disease, you must check against a null distribution generated by permuting the disease status across individuals. This ensures the association isn't due to population structure or genotyping artifacts. In cosmology, a claim detection of a specific pattern in the cosmic microwave background, like non-Gaussianity, must be tested against thousands of simulated CMB maps with Gaussian random noise, but the same instrumental effects. If the pattern appears just as often in the null simulations, it's not a discovery. In psychology and medicine, every clinical trial is fundamentally a placebo test. The placebo group is the negative control for the specific biochemical intervention. Finally, let us summarize the epistemic function of this part. Let us crystallize what we have built. We have defined negative controls and placebo laws. This firewall mechanism mandates that any candidate rule be tested against deliberately constructed null worlds, where the specific omega kV structure it posits has been destroyed. A rule that appears in the null is a placebo, an artifact of the pipeline or chance. The firewall acts as a null world architect. It demands the construction and application of tri-unity negative controls, omega scrambling, K randomization, V decoupling, and compares the rule signal to the null distribution. The explicit prediction for a real rule is demise in nullity. The rule signal vanishes or becomes statistically insignificant when tested on properly scrambled data. The explicit falsification condition is survival in nullity. The rule remains robust in negative controls, proving it is a hallucinated constraint. The license consequence is the rule is downgraded, its failure is recorded, and a mandatory pipeline audit is triggered. This strengthens the firewall by providing the definitive false positive filter. It is the mechanism that separates signal from noise, structure from artifact, discovery from delusion. With this, the firewall can not only validate true rules, but also conclusively expose false ones, keeping the registry clean and trustworthy. Now, even with perfect placebo tests, a final challenge remains. What happens when two independent teams, both using rigorous methods, arrive at conflicting rules for the same phenomenon? How does the firewall resolve honest disagreement without devolving into tribalism? This requires a pre-registered adversarial collaboration protocol. Salam, and peace be upon you.